Hi everyone, I'm going through the study guide for the Unit 1 test in detail, all the right answers, everything you need to know. This will be really helpful if you understand everything in the video, then I'm sure you'll be great for the test. So the first question, we have key concepts and vocabulary. It says the pre-image and the image after a translation, rotation, and or reflection are always blank, which means they have blank. So if we look at the word bank, we have similar, congruent, same shape and size, same angles, and proportional side lengths. So for the pre-image and the image, after a translation, rotation, or reflection, those shapes are always congruent, which means they look the exact same. They might just be in a different location or facing a different direction. And congruent means the same shape, which also means they have the same angles and the same size. Okay, which means they have the same side lengths. So they are the exact same shape, same size, same angles, same side lengths. All that's changed is their location or the direction that they're facing. Then we have two, the pre-image and the image after a dilation. Those are always similar. Okay, we have similar figures or figures that have the same angles. So their angles are the same. And what we call proportional side lengths. Okay, so as a quick reminder of what that means, it means if we have like this triangle, this is a side length of 1, that has a side length of 2, and then I have this triangle, this has a side length of 2, that has a side length of 4. Even though those side lengths aren't the same, the ratio of the side lengths are equal. 1/2, 1/2 is equal to 2 divided by 4, 2/4, which is equal to 0.5. So they don't have to be the same size, but there is this relationship with the side lengths. And we definitely need to know that they have the same angles. So after a translation, rotation, or reflection, the pre-image and the image are congruent. After a dilation, they're similar. That takes us into our first question. Explain why figure B is not the image of figure A after a rotation around using center C. Okay, so if I look at A and then I look at B, I should notice something. I should notice that these are not the same shape. Okay, more specifically, or in better math language, A and B are not congruent, right? Between a rotation, as well as a reflection or a translation, the pre-image and the image have to be congruent. But that's not the case here. So this is not an image because figure A and B are not congruent figures. So a rotation can't take one to the other. These are not congruent, so we cannot get to the image. We can't get from one to the other by rotating because they're not congruent. All right, similar trend here with 2. A sequence of transformations was applied to a square in a coordinate plane. The transformation used were rotations, reflections, and translations. Which statement about the resulting figure is true? Is it A, that the resulting figure, the image, does it have to be a square with the same side lengths as the original square? A square but with different side lengths as the original? A rectangle, and all the side lengths may differ from the original square, but the angles must stay the same. Or it must be a rectangle with at least one side the same length as the original square. So for a multiple choice question like this, we want to read them, but then take a second to relax, think about what we know. We have some square, and then we're just rotating, reflecting, or translating. The pre-image and the image have to be congruent because the pre-image and the image after translation, rotation, and reflection are congruent. So the original square and then the resulting image have to be congruent. which means they have to have the same shape and the same size. So if the original one is a square, it has to be a square. Okay, can't be a rectangle, has to stay a square. And it has to be the same size too, since we're not dilating, we're just rotating, reflecting, or translating. So we have to have the same side lengths as well. Okay, so A is the right answer here. All right, moving on to 3. Rectangle ABC will be translated. So the coordinates of B prime are 4, 3. What will the coordinates of D prime be when this translation is applied? So currently this is B. B is the point 2, 2. Okay, and after this translation, we have 4, 3. This is B prime. Now, something we know about translations is we're shifting the shape, and we're shifting all the points the same direction and the same distance. So what I could do, I don't necessarily need to do this, but I could use tracing paper. Trace my shape. And I'm going to just slide it, because that's what translating means, so that we get B prime to be where it needs to be, 4, 3. Okay, and then we have to figure out where will D be. Well, D is going to be right there. D prime is going to be right there, because we're just sliding the shape. Okay, without tracing paper though, we can see that to get from B to B prime, we're going right 2, and then up 1, right 1, 2, up 1. So to get D prime, we also need to go right 2, and then up 1. Okay, so the answer to this question is that D prime will be this point 4, -1. So you take the original pre-image D, and you go right 2 and up 1. Awesome. All right, question number 4. Rotate triangle ABC about the origin 270 degrees. Label the image of the triangle A prime, B prime, C prime. So this is another one where tracing paper might be helpful, although we did learn how to do this without tracing paper. So we're going to talk about it both ways. As a general idea, we could trace our shape. Okay, and then we are rotating around the origin. So the origin is our center. And we're spinning clockwise, that's that way, 270 degrees. That's like 3/4 of the way around. So this would be like 90 degrees. This would be like 180. And then this is going to be 270. Okay, we're spinning it 270 degrees around. So we can now plot the points. But there was a little bit of guesswork in that that's exactly 270. So that's why we have the coordinate rules. And I'm actually going to project these on the board for you during the test. I'm not letting you use your notes, but I don't think you need to memorize these. So a 270 degrees clockwise rotation. In our notes, we said it takes a point XY, and it becomes the opposite of Y, comma, X. So what does that mean? So here's point A. That's the point 1, 1. So then to get A prime, you're going to take the original Y coordinate, which was 1, and take the opposite of that. That's -1. And then the X coordinate comes next. So A prime is going to be right here at -1, 1. Okay? Then let's take B. B is at 1, 5. Okay, so then I'm going to follow this rule again. For my Y, I get the opposite of Y. So the opposite of 5 is -5. the opposite of x, or no, we just have x, sorry. And then that becomes the new y coordinate. So we get -5, 1. That's my new b prime. And then finally I'll do the same thing with c. C is at 5, 2. Follow the coordinate rule. That becomes -2, 5. All right, so that is right here. So we can go back to our original. Check this out. With the tracing paper, it's there. We're spinning not 90 degrees clockwise, not 180 degrees clockwise, but 270 degrees clockwise. And when we do that, it should look right like that. Okay. And we label it A prime, B prime, C prime. All right, moving on. Problem 5. Which of the following sequences of transformations would map K, L, M, N to K prime, L prime, M prime, N prime? Select all that apply. So we are starting here. That is the pre-image. This is the image. I know that from the primes. So how can we get from here to here? Okay, let's use some tracing paper again. Trace my shape. If I rotate it 90 degrees counterclockwise around the origin, that's going to put it up here in the first quadrant. Okay, 90 degrees counterclockwise would go up there. So that is not the right answer. All right, but let's try 180 counterclockwise. Hold my finger there. Translate up and around. See how that works out? It's a perfect match. So going 180 degrees, spinning this around, that is going to be a rotation. 180 around the origin. Okay, but this is a select all that apply question, so I'm going to keep going. Could it be a rotation 180 degrees clockwise? Yes. Okay, instead of going counterclockwise, I could also have gone 180 degrees clockwise. Since it's like a half turn, it doesn't matter which direction you have, you still end up at the other half. So this is the same as going 180 degrees clockwise. Then in D, it says a reflection over the x-axis followed by a reflection over the y-axis. All right, well, let's try that out. So we take this. This is my x-axis. If I reflect over the x-axis, I'm right here. Okay, that's looking promising. Then here's my y-axis. We reflect over my y-axis. And again, we can see perfectly lines up. Okay, this is a key concept that we've kind of talked about, but not super explicitly, that will show up on the test, which is that rotating 180 degrees around the origin, that's equal to reflecting over the x-axis and the y-axis. So there's not a thing like this for everything, but to get 180 degree rotation, that's actually the same. It's always going to be the same as rotating over the y and then rotating over the x. Okay? And then finally in E, a reflection over the x-axis. Let's try this out. We got this. We reflect over the x-axis. And then we're supposed to reflect over the x-axis again. Nope, that's going to take us back to where we started. which is not the image which we want. So that one isn't right. Cool. All right, moving on. D, write a sequence of transformations that takes pre-image A to its image B. Does the order you apply your sequence in affect the image in this case? So I'm trying to get from A, that's my pre-image, to B. How do I do that? Well, looking off at these, off the bat, I can see that this appears to be a sort of reflection going on. These shapes are like looking at each other. They're facing each other. We have like a mirror situation, or we could get one. So I'm going to start by doing that. I'm going to notice that we could reflect over the y-axis. So I'm going to do that first. First, reflect over the y-axis. Okay, when I do that, this will be my picture. That would be like A prime. We reflect over the y-axis. Okay, now it's looking pretty good, but they're not in the same spot, but they do appear to be facing the same direction. So now we can just slide it up 1, 2, and then right 1, 2. And it's going to perfectly match. Then up 2 units and right 2 units. So that's the first part of the question. That's the main thing. But then it says, does the order you apply your sequence in matter? So basically, instead of reflecting over the y-axis first, could I have gone up to right 2 and then reflected over the y-axis? So let's just try it with my tracing paper. There's my original. I start out by going up 1, 2. Then I go right 1, 2. And then if I reflect over the y-axis, it's going to end up right there, which is not B. So in this case, the order does matter. It doesn't ask us to explain, so we can just stop it there. That won't get us to the right spot. This is not the only sequence we could have done, though. Another one we could have done is we could have gone up to left 2 first. We had done that. A prime would have looked like that. And then we could have reflected over the y-axis, and that would have worked. So another possible correct answer, if you did it, is you could have translated left 2 and up 2, then reflect over the x-axis, or the y-axis. Both of those are right. That's probably another way to do it too, but those would be the clearest ways to do it. Now let's go on to 7. Describe a sequence of transformations that prove similarity between figure PQTS and P prime Q prime. That should be R. Sorry. RS and P prime Q prime, R prime and S prime. Okay, so we know that two figures are similar if there's a sequence of transformations that can take us from one to the other. Similar also means they have the same angles and their side lengths are proportional. So basically here we're trying to describe a sequence that takes us from this small one to the big one. Okay, so it's getting bigger. We can see that kind of pretty clearly. So to do that, to change the size, we need to dilate. So first, actually I think this might be all it is. Dilate with a scale factor of something and a center something. Whenever we describe a dilation, we need those details. So we did talk about how we can find the center, though. You draw lines between all the corresponding points, and all of those lines meet at the origin. So the center is the origin. If we're not sure, that's a pretty good guess that the center is the origin. And then we just have to find the scale factor. So the small one, that's the pre-image. I can tell that by the way they label the points. The big one is the image. So this shape is getting bigger. That means it's an enlargement. Okay, and how much bigger? Right, how much bigger is it getting? We can do that a few ways. So one way is we can say from that center, from the origin to S, we go up 2. And then from the origin to S prime, we go up 1, 2, 3, 4, 5, 6. So there's some scale factor that we multiplied by that got us from up 2 to up 6. So our question is 2 times what equals 6? That's going to be our scale factor. 2 times what is 6? That is 3. Okay, so we're getting 3 times as big. We can check that in other places. The length of Q P here, this is 1 unit. The length of Q prime P prime, this is 3 units. Again, it's getting 3 times as big. Okay, and that's it. That's actually going to do it here. On the test, you might see one where first you have to dilate and then you translate it, which is why I have this as a sequence, but in this problem, you actually only need to do one thing. There's other ways you could do it if you had different centers, but that would do it in this case. Okay, and now we have 8. Now 8 is a question that I promise you is not that hard. You might just look at it, feel like there's a lot of words, and decide to give up. There's a question just like this on the test. Don't give up when it happens. So we're told in the diagram below, lines MN, this line, and JK are parallel, meaning they never intersect. And they're intersected by line QT. So that line crosses them. Which transformation could be used to show that angle NRQ is congruent to angle KSR? Okay, so this is N, this is R, and this is Q. So that is angle NRQ. Then we have KSR. This is K, this is S, and that's R. So that is angle KSR. Those angles are congruent, meaning they're the same. They're the same angles. Okay, so what transformation could show that they're the same angles? We're trying to take this angle and get this angle. Okay, if we look at them, we see the angles are currently facing the correct direction. So that means we need to translate. Okay, but if we reflect it over the x-axis, that wouldn't make sense, then our angle would be down here. If we rotate, we wouldn't want to rotate our angle. There's my original angle. Okay, I just need to slide it down and to the right. And it lines up with my new angle. I take my original NRQ, I translate it down to the right, and you get angle KSR. Now, we're not dilating it, it's the same angle, we're just sliding it down. Okay, so that's all that one is. You just gotta identify the angles. All right, and that's it. So on the back, we should write down some things, anything we need to study that we don't know. Okay, this is the test. It's not the actual test, but it's very close to the test. So if we understand everything in this video, then you're going to be in great shape. Okay, watch this as many times as you need. Pause it Ask me for help if you have any questions and you're in class. Okay? Glad you watched it. Good job, everyone. Good luck tomorrow.